Okay, I made a sort of off-topic post on this Lua Reddit thread because they were asking a question about this, but what caught my eye was actually the Boolean being passed into the function, which I think is a bad idea. I posted as much, and someone here, Josh B. Adams, says, not like you know, he recommends posting a way to rework the bad example I give. So if we go to follow this link to my Substack where I talk about Boolean flags on this post, I actually say exactly how you can deal with this problem using enums in various different languages, not Lua. Lua doesn't have enums, so fair enough. And it was totally off topic, so it's not really a Lua only thing. And the bad example I give it at the end, like if you don't follow the advice, which is essentially as soon as you see something that says like is automatic or has ammo, as soon as you see has is and is, then walk away, or else you get code like this with lots of ifs and testing for booleans, etc. So my point was you'll end up with code like this if you don't watch how booleans sort of come together, they cluster up together. So I thought maybe I'll give it a go, even though the purpose of this post is to say don't do this and walk away as soon as you start finding yourself doing it. Like in this part, Boolean never walks alone. But fair enough. Maybe I could show how to refactor this, but because I'm not really into going deep into C#, I'll do it in Lua instead. And then I can post back to this guy and say, look, okay, fair enough here. Although I think there's enough information in this post to sort of warn you off. Okay, so that's what I'm going to try to do. I've set up, so I've converted this C# code, which is, if you go onto Reddit, someone asked, how can I fix this on this post in Reddit? And I say, the problem is too many Boolean flags. So, how can you fix it? I'm going to say, this is how you fix it. And we'll give it a go. So I've converted the C# to Lua. There's a couple of functions, has ammo, and I'm just returning this flag. Obviously, you'd probably have a count of ammo and it would return, if that counts more than 0, you have ammo. Barrel blocked, who knows, but I'm just having a flag here. We've also got this number of flags. So is it an automatic weapon? Let's make that true. Is it already firing, I guess? Is it reloading? There's a time since fired, so maybe that's 0. And there's a cooldown period, which is a kind of constant by the look of it. Let's say it's 1 for a second. I don't know. Okay, so this is the code we've got, which is pretty much a translation of the C#. In fact, it is. So I would normally, when you're refactoring, first of all, you have to have some tests that you can check whether it's working or not. If I run this, I get a false. So basically, if you're holding the gun, the basic answer is you can't fire it. Let's see what it would be if we put in false. Well, that doesn't seem very clever. So let's just go through this. I'm holding it. Am I reloading or is it firing? Okay, so obviously reloading would stop the gun from firing. And we're going to say it's not firing either. Let's just see if we can get a... And I think holding doesn't mean you're physically holding the gun. I think it means you're holding the trigger in. So there's a bit of a name issue there, but I think I've worked that out. Right, so run those tests, false still. So is it reloading? Is it firing? Is it automatic? Let's make it false. Do you see? We're already... If it's holding and it's not automatic, then return false. Let's just check the C# code. If you're not holding, if you haven't got ammo, it's just impossible to understand. If you haven't got ammo, has ammo is true. So you do have ammo. But if you're holding and it's not in... Oh, so it's difficult. I'm just trying to get true out of this. If it's holding and it's not automatic, otherwise, if time since fired is less than fire cooldown, then return... Right, so time since fired has to be bigger than cooldown. Okay, so I'm going to get a true. Yes, we can get a true. True. Okay, now there are, as I said in my article, right, so we probably want to make... There are... This should be... Let's make that into a function, that comparison, just so... So... Ready to fire? And let's use the... So they haven't been consistent. Right, ready to fire. Let's take that out. Obviously in C#, this is a class, but we have not got classes, so we're going to do like this. Right. Right. Okay. So we've got 1, 2, 3, 4, 5, 6, 7 different Boolean values that can affect the return value of this. Now, if you think about that, if we made a truth table, we'd have 7 columns. Like you'd have to go all true. So let's use capital T as true. T, 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 T. 1, 2, 3, 4, 5, 6, 7. And how many of these? So this is, we'd need 127 entries to test. It's just, even that just makes me sigh. So you do genuinely have 127 states that end up with a can fire or can't fire, true or false value. So how do we get rid of all of this? Well, the first thing we're going to do is split it into two functions, because the Boolean that you are sending in is basically splitting this into two functions. So let's just quickly do that. Okay. So okay, so we're going to get rid of the holding, just that's now true. Assume that's true. So if not holding, so that's true. If holding, so if not holding, hold on, undo. This LSP means I have to call the function. So we're going to replace holding with true. If not true, well, that can't be true ever. Yeah. If holding is true, if not true, well, that's always false. So we can get rid of that. Which means we can get rid of that. If true, and so we can get rid of that. Okay, simplified that, and then do the other one for false. So if not holding, that's now true. So this is the bit that always plays the empty sound. Okay. I mean, you shouldn't be doing this inside of this, to be honest. What we do is we'll deal with that later, but this side effect shouldn't happen in the middle of this. Honestly. So this is false, so this is always false. Get rid of that. Oh, so hold on. If holding and not automatic. Yeah. Now, so that is basically we're going to essentially move the holding to, so the way I would do that in Lua is I would have a table of true confirmed. Yep. And I would call it with print can find look up it with basically a holding variable. Right. So basically we've taken the decision outside the function. So got two very similar functions. we sort that out. But one we call with the true flag, and one we call with the false flag, and we look it up. In Lua you can do a lookup on like that, and then we call the function. So that's sort of step one. Get rid of the Boolean argument, split it into two functions. They're almost the same. There's only this difference, and the reason is one's automatic and one isn't. So and it seems to be the only one that cares about no. No, we still need that. If so, we still have that. We still just return false from that. Okay. So those are the two functions. The only difference is the holding flag is either taken as red true or taken as red false. So it doesn't play the empty sound for in the holding case. Struggle this if it's not holding. Don't understand the logic there, but this is step one. Step two is reloading or is firing. Now, are these really different? Can you be firing and reloading at the same time? I don't think so. So I think you have these two states are part of the same state. So we're going to have state and this is going to try and let's make it, this is kind of like an enum in another language. So we'd go open state. Okay. Now the gun state it's either reloading or it's firing. So it can be reloading. Or it could be ready. Right? What does this say? Same loaded. So get rid of those two balls by going if we could probably have empty. We'll add that in a minute. So you'd go, okay, if state loaded, not loaded. If it's not loaded, then we can return a box. Oh, okay. And we'll put that in there. Place those two. So that's kind of step 2. So step 1, remove the Boolean duplicate functions. We'll get to merging, making this a single function back later. Step 2 was to replace the reloading firing booleans with this state, because there's actually 3 states. You're either loaded and ready to fire, you're reloading, or you're firing currently. Now, not has ammo. Well, you'd think that loaded would, you can't be loaded if you don't have ammo. Okay, so we'd probably have another one empty, for instance. Okay, so we get rid of that one. And again, we have this weird right. If it's empty, then we're going to play this sound. Although we've already returned here, so we're probably going to take this test out, and that's going to go here, right? If it's empty, then we can't fire. But we also just want to play the sound. And it's kind of weird here. The trigger's been pulled. So we probably want to make this into... So I think we'll ignore this side effect, which shouldn't have been there in the first place. But you can imagine that this code is being called, trigger's been pulled. Let's make it into a function. Let's call the function. Okay. So here, so the trigger's been pulled. Then we're going to call one of our functions. We're going to look up it based on whether you're holding the trigger or not. Again, it's not how to do it, but once we've looked up, we can call the function. Okay, So these look identical now, pretty much, apart from this automatic one. So again, really we've got an automatic weapon and a non-automatic weapon, all hidden under this flag. So what you really want is an automatic test before you call it. So in the holding, if it's not automatic, then you return false. So really we've got trigger held and trigger pulled. So what we really have, trigger held, and that's going to be the one that calls campfire holding. And you go print rid of that. Trigger pulled then becomes, and that was the one that had that weird thing. So trigger held becomes different to trigger pulled. Let's just call it, sorry. Trigger pulled, we no longer need that variable. We can just call if can fire not holding print pow, or what did they say in Cousins? Crack. So we can get rid of that. Right, basically automatic weapons pull the trigger by holding it. So they have that test there. So these two, if it's not an automatic, so holding a trigger work on a non-automatic. So the way you would do this is you'd subclass in another language, but we don't have subclasses. So what we're going to do is we're going to go automatic weapon. It's just going to have a can fire. This is we're going to use a polymorphism. So the automatic weapons can fire does this. If it's empty, boop boop, it makes the sound. And then it goes. And if you're holding the trigger, We're just going to copy that. So I'm going to move this code into here for now. And then, because I'll delete it in a second. It's a non-automatic. And then it's can fire. It's going to have a can fire function. And it's going to be what we had here. And then we're going to have these. They're going to have a state. And nowhere we need to reference. There's no self in here, but oh, we won't worry about that. And then what we would do is like call it differently depending on if we've got a hold. So we would offer up full trigger. Which is a function. And we're just going to go if this won't work as Lua code, but it's the illustration that's important. So if it can fire, then okay, and we would end up with a hold trigger. Right, which basically all pull trigger. Let's just say defers it to pull trigger. Yeah. And then for the manual one, we take those two, but we would not do anything. So you can call for the non-automatic weapon, you call a hold trigger, it just doesn't do anything. Pay there. It's just not doing anything. Okay. We've still got this duplication code. Now this is always automatic, so that's never true. So we can get rid again of that. Now this code here, ready to fire, well, we've got that in the state, so it's ready to fire. That's a function, but we've already got loaded, so that's kind of ready to fire. So we don't need that. And we've got barrel blocked again, so that would be in the state. Barrel blocked. Okay, so we can get rid of that. So basically we have, I would put this stuff in the pull trigger. So we've basically got campfire. It's just, are we in state loaded? So it would be return so we could maybe even change the name of it. Loaded and ready to fire. And the same here. So here we go. So you're getting, that's basically, we've got a state. Now, when you pull the trigger, okay, and this is non-automatic weapon, so that's going to go crack. Just this, okay. Here, you're firing, you're changing the, what do we call it? Time since fired. So you change the time since fired to 0. You'd update, you could update the state to cool down, cooling down, say, add that in here. Again, in another language, this is an enum, but the point is, all of these things are actually, if we just maintain the one thing, the one state, and then in this, what you would do is you'd set up a timer to, you'd have a kind of, to call, so say it takes a second to cool, what was it? I'd set up a timer here, right? So I go like after cooldown, what's it called? Fire cooldown. Execute this function, which sets its state to ready. Okay. Now we make a function. So the point is, we're taking all of the booleans away. We're actually saying the gun has a state. It can only be, it can't be two of these things at once. It can be either firing or reloading or loaded and ready to fire. Or it can be empty. Or we can have the barrel blocked. Or it could be cooling down. And you just manage the transitions between the states. And then this becomes trivial. Is it loaded and ready to fire? You just know. And the way you just know is like as you fire, so again, we pulled it, say in our pull trigger function, we do the sound crack. We set the cooldown. We don't even need the time since fired anymore because we set this kind of, imagine after is like delaying fire cooldown seconds and then sets the state. Okay, so we don't need to know anything more. We just, this time is going to do it. We're also going to, decrease the ammo. And if that new ammo is 0, then guess what? I'm going to set the state to empty. And so on and so forth. So we, rather than having Boolean flags, we have one thing called state, and that's what we and that's what we put in. So we end up with, and for this case, we end up with pull trigger and hold trigger, which is the difference between an automatic weapon where you can hold the trigger and it continues to fire, and a non-automatic where you hold it and it doesn't. So holding a trigger on a non-automatic weapon does nothing. Could maybe, that's all, it does nothing. Whereas in an automatic it would just call pull trigger because it's the same thing. Again, this is all you need to do. And rather than do if can fire, I would always do if not, then return. Then get rid of this down here. And just simplify everything. So the point is, even without classes, and obviously this doesn't work because it's Lua and I haven't written the tape, I haven't done everything you need to make this work and do it, but I think hopefully this is the sort of the thinking behind how you get rid of the booleans. There's now no boolean, frankly, and in the not can fire, frankly, we could just basically get rid of that function entirely. And just when you pull the trigger and you're not loaded and ready to fire. So it would make more sense if state not equal to, then return. Otherwise we're going to do the side effect, print crack, then we're going to change our state. So first of all we're going to cool it down and we're going to change that. But if we're empty, then we just empty. So on, you can manage this one variable, the state, between these different states, and that's how you do it. And then you cool, in the cooler, instead of passing the holding boolean to can fire, you either call pull trigger or hold trigger, depending on whether you're pulling the trigger or holding the trigger. So you make the decision outside before, and then you don't have to have this boolean confusing functions. So hopefully that's useful. Yeah, don't use booleans if you can help it, turns out. Right, if you've got a proliferation of booleans, then it's probably the wrong representation. Okay, thank you.